Hello all, I am Saranya from Information Technology Department, Hindustan Institute of Technology, Coimbatore. Very good to see you all here. Today we are going to see about the basics of Internet of Things. Okay? Okay. What are all the topics we are going to see here is introduction to Internet of Things, some characteristics of IoT, history of IoT or how Internet of Things has been evolved, IoT devices versus computers, what is the difference between computers and IoT devices, then basic components of IoT devices, IoT configurations, architecture of IoT and some applications of Internet of Things. Let's go into the topic and see the introduction. First, the definition. Here, the definition to Internet of Things refers to a network of physical objects that all are embedded with sensors, softwares, and communication technologies, enabling them to connect to the Internet. So, if we have Internet only, we can make a normal device into IoT device, right? Them to connect to the Internet and exchange data without direct human involvement. That is the main thing. Without the human intervention, we are going to enable the Internet and we are going to make a device work without the human intervention. Okay, next, Internet of Things is a network of physical objects that are all embedded with sensors, softwares, and different communication technology, and all are connected to the Internet and exchange data without human intervention. Okay, so this plays a key role in modern networks. So, Internet of Things is very common thing that we are using here. So that improves efficiency, accuracy, convenience in daily life. Next one, introduction. The mainly it focuses on connecting everyday physical objects such as devices, machines, and systems to the computer networks. Okay, everyday devices that what we are using devices into the computer network. We are going to make it possible using the computer network and with the internet. So it enables real-time data collection, monitoring, and automated actions. Some of the examples are smart homes, smart watches, smart vehicles, and smart agricultural things. Next one, IoT ecosystem. Next, we are going to see about IoT ecosystem. First, in IoT ecosystem, these are all the things that we are needed to make a normal device into an IoT device. First one is environment. Environment, what is environment? It represents the real world physical environment like smart home, smart vehicle, human beings, everything. Okay, Smart environment consists of these things. Next one is sensors. The next important thing is sensor, which detects physical parameters from the environment. For example, temperature sensors, humidity sensor. Temperature sensor senses the temperature of the environment. Humidity sensor sense the humidity that is available in that environment. Then motion sensors, gas sensors, etc. And next we come to microcontrollers, which it acts as a brain of the IoT systems. It receives the data from the sensors and processes it and controls the actions based on the programmed logic. Examples: Arduino, Raspberry Pi, Node MCU. So this is the main important thing of the microcontrollers. Okay. Next one is actuators. It performs physical actions based on controller commands. Example, motors, LEDs, relays, etc. This is used to automate the work, automate the task. Okay, next one we can go for internet. Okay, all we know what is internet. Used to connect the IoT device to the cloud services and users. Okay, we are going to connect our IoT device to the cloud services and with the users. Okay, so it enables remote monitoring, remote controlling and data sharing, etc. Next one is interfaces. Okay, what is interfaces? It provides interaction between users and IoT system devices that is used. Here, computers, smartphones, tablets, etc. are all the interfaces. Then users. What is user? End users who are all going to use our IoT device is known as the end user. Next one, some characteristics of IoT. Okay, so we are going to see what are all the characteristics of the IoT. First one, connectivity. IoT devices are connected through the internet or communication networks. It enables communication between the users, devices, and cloud platforms. Some technology used are Wi-Fi, Bluetooth, Zigbee, cellular networks, etc. Okay, next one, intelligence and automations. IoT systems use smart processing and decision-making capabilities. Devices can automatically perform actions without human intervention. Next one, sensing capability. IoT devices use sensor to collect information from the environment. Sensors detect temperature, humidity, motions, pressures, and light, etc. Next one is real-time data collection. IoT continuously gathers and processes live data that helps immediate monitoring and quick decision making. Example, real-time health monitoring system, etc. In real-time health monitoring system, the data are monitored, live data are monitored and immediate monitoring whenever it is necessary. Then heterogeneity. IoT includes different types of devices, platforms, communication technologies, etc. Devices from various manufacturers work together in one network. That is the property of heterogeneity. Scalability, which means it can support a large number of connected device. Networks can expand easily as more devices are added. Okay, next one is dynamic nature. IoT devices frequently change status, location, connectivity, etc. It dynamically adapts environment and operational changes. Next one is self-configuration. IoT devices can automatically configure themselves in a network. Even a failure occurs, it will self-repair itself and work together. Next one is security and privacy. Protects IoT devices and users' data from cyber threats. It includes authentication, encryption, access control, etc. And the last one is interoperability. Different IoT devices and applications communicate and work together, achieved through common standards and protocols. So these are all some of the characters. We have many more characters of IoT. These are all some of the characteristics of IoT. Next, we are going to see about how Internet of Things has been evolved, when it is evolved. So that means history of Internet of Things. Okay. First, in 1980s, okay, in 1980s, the idea of connected devices has begun. See, at one at Carnegie Mellon University, a Coca-Cola vending machine has been used, and first it is connected to the internet, and it is used as a vending machine, which is also an basics of Internet of Things. In 1990, Internet emerges. Here, the Internet expands rapidly. Embedded systems, wireless technologies improved in Some enables the identification and tracking systems. In 2000s, growth of sensor and wireless network increased. Increase in mobile devices and cloud computing. IPv6 introduced, so it supports different devices, billions of devices to a internet. So here in 2000s, smart home, healthcare, tracking devices have been emerged in this era, that is in development phase era. In 2010s to 2020s, rapid expansion of IoT devices has been grown. It grows throughout the worldwide. Cloud computing and big data analytics also makes the IoT devices work more efficiently, especially in smart homes, wearables, smart cities, everything, etc. Next, in 2020's present, integration with AI, that is integration of IoT with AI, ML, and 5G network, blockchain, edge computing, etc. Applications in autonomous vehicle system has been also been improved. Healthcare, agriculture, everything in each and every environment, IoT has been developed, and we can so some technologies like sensors, RFID, artificial intelligence, security, everything has been encouraged in IoT. Next one, IoT devices versus computers. Then, what is the difference between a normal computer and IoT devices? Here we can see what is the difference. First, computer. Computer is an electronic device used for general purpose computing and processing. Whereas IoT device is a smart device connected to internet for sensing, monitoring, automation, working, etc. According to the primary purpose, we consider IoT device works only for a specific task. This is a multi-purpose user-defined task. It works for multiple user-defined. Okay. When compared size is compared, IoT devices are usually small and compact. When for computers, these are all large compared to IoT device. Okay, processing power. IoT devices have limited processing capability, while computers have high processing capability. Human interaction. Minimal human interaction is needed in IoT device, and computers require direct user interaction for everything. Connectivity, always connected. IoT device needs to be always connected to the internet, while computers may or may not be connected to the internet. When power consumption is considered, low power consumption is for IoT devices and higher power consumption for computers. While storage capacity is considered, IoT device uses limited storage and computers use a large storage capacity. When real-time monitoring, it is designed for real-time sensing, and these computers are mainly used for data processing applications, everything and all. Mobility. IoT devices are portable. We can carry to anywhere and use it anywhere. Then it is portable or fixed type computers. Cost, generally low cost compared to the computers. Examples of IoT, some examples are smartwatch, bulbs, sensors, fitness tracking systems, etc. These are all laptop, workstations, desktop computer, etc. Okay, these are all a diagram for IoT devices versus computers. See, some of the IoT devices are smart plug, smart watch, camera, smart bulb, smart thermostat, smart sensor, fitness tracking devices, smart speakers, etc. And computers, desktop computers, laptop, as you all know, servers, workstations, supercomputers, etc. Okay, these are all the features when compared to IoT devices and computers. Some special features. Next one, some of the basic components of IoT devices we are going to see. IoT, some basic components of IoT devices include sensor, processors, communication modules, power supplies, firmware, cloud platforms, user interface, etc. Together, these components all enable together and work accordingly to form an IoT device and across the that work across the various applications such as smart homes, healthcare, agriculture, industrial automation, etc. These are all the basic components. We will see one by one. Okay. See, first one is sensor. As we have already seen, sensor. What is the work of sensor? It detects physical parameters from the environment. Okay. Next one is actuators. It performs physical actions based on the controller command. Okay. Then the software, embedded software devices, everything the needed things are all here. And we need the microcontroller, which is the brain of the IoT. It processes data, controls operations, executes programs. Then power supply, as we already seen, the main thing is power supply. We needed power supply. Then connectivity module, some protocols such as MQTT, HTTP, Zigbees, etc. And memory for storage, storing our data or real-time storage. Then security, authentication, encryption, everything. Then some user interface from where we are going to use our devices, through which we are going to use our devices, user interface, then connected to the cloud and the internet. Okay. Next one, IoT configurations. Okay, how we are, what are all the types of configuration we can do with the IoT devices? And the first one is device to device configuration. Devices communicate directly with each other without any cloud supports. Okay, some of the features is short range. It helps short range. It responds immediately. Low power is consumed, etc. Here, the technologies used are Bluetooth, Zigbee, NFS, etc. So short communication, we can say. Example: smart bulbs connected to smart switches. Okay, in a smart home, for a smart room, here we have connected smart bulbs. So we can use it through a smart switch which is there in that room. The next one is device to cloud configuration. Okay, devices sends data directly to cloud servers using the internet. Here, some features are remote monitoring, large data storage, real-time analytics, etc. Here, main example is smart home security, that is CCTV camera. Uh, we have put CCTV camera on our phone, and we can view the real-time images and videos from wherever we are there. Next one, device to gateway configuration. Device is first connected to a gateway, then gateway communicates with the cloud. Some of the features are improved security, protocol translation, data filtering. One example is industrial sensors connected through Raspberry Pi gateway. The next one, IoT configuration. Fourth one is back-end data sharing configuration. That is, different IoT systems share different data through the cloud platforms. For example, smart city traffic system, which data are shared with emergency services. If any accident occurs, an ambulance will be immediately called, like that. Okay, some features are data integration, cross-platform communication, big data analytics, etc. Here the diagram for end-to-end IoT system architecture. Okay, here devices, sensors are connected, whatever the devices it may be, the devices are connected with the sensors. What sensor if temperature sensor is needed, we will be connecting with the temperature sensor, humidity sensor, motion sensor, anything. Devices are connected with this, communicated with sensors, and connectivity. Next one, we will be connecting through Wi-Fi, Bluetooth, Zigbee, anything it may be. Okay, short range means we will be connecting through Bluetooth. Long range means we will be connecting through network Wi-Fi. Then gateway. If gateway is needed, we will be using a gateway. Then if for a real-time applications, we will be using cloud platforms, and user applications such as we can view our data in a mobile app or a computer, or any alerts or notification. Everything is directly communicated with the security layer, management and security layer. Here everything is managed and security is attained. Then everything will be monitored real time. Okay, next one, architecture of IoT. Okay, we will see the basic IoT architecture layers. Depending upon our application, there will be 4 layers or 5 layers architecture. It defines the structure and organization of the IoT that connect physical devices, communication network, data processing system, applications that enables smart services and automations, etc. Okay, the first layer is perception layer or sensing layer, that is sensor. Here we are using sensor, so this layer is known as sensing layer. So it collects the data from the environment, identify objects, monitors physical parameters, etc. Some of the components or main components of sensors: camera, GPS modules, actuators, etc. Okay, here examples: temperature sensor measures the room temperature, motion sensor detects the movement wherever we are going, GPS informs the location, live location. Okay, next one, network layer or transport layer. Here the data are transferred from devices to the processing environment. Some functions are data transmission, device connectivity, communication management, etc. Okay, example: sensor data transmitted through Wi-Fi to cloud server. Next one, processing. Third layer is processing or middleware layer. Here the processing occurs and stores the collected data. Everything will be collected. Data analytics is performed. Everything is managed, stored, and the decision making occurs here. Some of the components here are cloud computing, edge computing, databases, etc. Some example: cloud server analyzes the smart home sensor data real-timely. Fourth layer is application layer, which provides services to the end users. Here smart homes, some of the applications are smart homes, healthcare, agriculture, etc. Okay, okay. Now the diagram for architecture of IoT layer. First one is sensing layer. Here sensors are used. Next one is transport layer. Data are transferred to the next layer. Processing. Here the processing occurs, storing, managing, everything occurs here. Application. Here we are using our IoT device. Okay. Next one. Some of the applications of IoT. Here Internet of Things, which is used in many fields to connect the devices, collect data, automate the process, and improve the efficiency. By connecting devices and enabling intelligent communication, IoT improves automation, monitoring, productivity, and decision making in everyday life and industrial environment. Some of the applications are: first one is smart home, that is smart lighting, security cameras, smart appliances, energy management, etc. In smart healthcare, some of the wearable device, smart watches, which we are wearing nowadays, patient tracking system, remote monitoring, hospital management, everything. Then smart agriculture, okay, uh, livestock tracking, weather monitoring, etc. Soil management, everything comes under this smart agriculture. Next one, industrial IoT, that is machine monitoring, predictive maintenances, and predictive automation, etc. can be monitored. Next one, transportation and logistics. In transportation and logistics, vehicle tracking, fleet management, the main thing is fleet management, traffic controlling, etc. can all be managed with the IoT devices. Next one, eighth one is smart energy management. Low consumption of energy using the solars, then smart meters, smart grids, everything comes under smart energy management. And next one is retail shopping. Okay, smart customer tracking, and automated billing system, inventory management, smart stores, etc. are managed through the retail and shopping IoT devices. Education, smart classroom, okay, library management, interactive learning, everything comes under education. Then IoT applications in defense and security, which is border security, surveillance system, intrusion detection, everything. And some other applications used in IoT devices are smart banking, smart tourism, smart water management, everything. Okay. So these are all the some of the implications of IoT using the cloud platform and data analytics. Okay. And next one. So we have seen basics of Internet of Things. Thank you. Thank you so much.